Isotope elements, 118 elements in the periodic table. Alright, so isotopy is a phenomenon by which an atom of an element having the same atomic number but different mass number. Alright, isotopy is a phenomenon by which an element table below shows elements and their isotopes. Elements and their isotopes. So here we have elements, isotopes, elements and their isotopes. Let's start with hydrogen. Hydrogen is an element. H21, H31. H11 is called protium. You know it's called deuterium. This one is called tritium. So these are the three isotopes of hydrogen. Alright? Sodium. We have sodium 2311, sodium 2211, sodium carbon 12,6, carbon 13, carbon 14,6. Oxygen. Oxygen 16,8, oxygen 17,8, oxygen 18,8. Let me take two more. Chlorine. Chlorine 3517 or 1735 and chlorine 1737. We have so many. I said the whole elements in the periodic. This is uranium. This is uranium. Dangerous element in the periodic table. You can use it to manufacture nuclear weapon of mass destruction. This is what America used to manufacture weapon of mass destruction. Weapon of mass destruction that destroyed Hiroshima and Nagasaki in 1945. Uranium. How many years ago? So, you have uranium 238, 92, and uranium 239. Very super intelligent. She defeated so many men. The daughter of this woman, she discovered in 1904. Alright? So, that is it. So these are isotopes. Isotopes of relative atomic mass of isotope. Calculation of relative atomic mass. That is RAM, call it RAM. Relative atomic what? Mass. And this. Why I'm not taking this? Because this one is a naturally occurring hydrogen. This one is a naturally occurring hydrogen. Why these are the isotope? Even sometimes this one included, but this one is naturally occurring hydrogen. But this is isotopic what? Hydrogen. So let's calculate the RAM of this and this. If you have two hydrogen, calculate the Calculate the RAM of the following isotopes. Calculate the RAM of the following isotopes. H21, 75%. H31, 25%. That's number one. Number two, carbon 12, 6, and ratio 1. Number three, 22, 11, 75%. Sodium 23, 11, 25%. Carbon, oxygen 8, 16, 3 ratio, oxygen 17, 8 ratio 1. Then the last one, uranium 238, 9 of this relative abundance of this what? Isotopes. Divided by what? 100. So you have 75 over 100 times the mass number plus 25 over 100 times the mass number. Oh yeah, do the working. Greater than the mass number of the first isotope, but less than the mass number of the second isotope. The RAM of any given isotope is greater than the mass number of the first isotope, but less than the mass number of the second isotope. After calculation, what you now get, whatever you get must be greater than 2, but will be less than 3 by 8, which is basic unit of life. And without the cell, no life. And what makes the cell to be alive is carbon 12. What makes the cell to be alive is what? Carbon 12. So you have to thank carbon 12. Then we have carbon 14. We use it for dating. I used to say time with time number. What is dating? Dating is trying to find out the age or ages of existence of artifacts or relics. That's what we call artifacts. Either I call it artifacts or I call it relics. Then geologists call it fossils. Geologists call it what? Fossils. Archaeologists call it artifact or relics. They are still the same thing. So 12.5 is not greater than 12. It's not less than 14. So that's it. So RAM of any element is greater